Hello. Good afternoon, everyone. I hope you all are doing good and having a great time. And I once again welcome you all to this wonderful platform by Unacademy NEET English. Well, my dear lovely students, before we move ahead, let me know in the chats if I am perfectly audible and visible to each one of you. Let me know in the chats if I am audible and visible to each one of you. Let me know quickly. Let me know quickly. Okay, dear lovely students, in today's session, we are dealing with amazing set of JEE Mains previous year questions of organic chemistry that I believe will boost your preparation to next level. So my dear lovely students, be with me till end of this session and also mark the attendance by smashing the like button. So without wasting time, let's get started. Let's get started today's session. But before that, let me tell you that I will be sharing the handwritten PDF of this session on my new Telegram channel, which is this one. Dear lovely students, today's session will be a maximum of 1 hour only, and I hope you will answer me each and every question today. You will answer me each and every question today. So, should we start? Should we start today's session? Let me know in the chats by sending fire emojis. Should we start today's session? Let me know in the chats by sending fire emojis. Come on, my dear lovely students. Come on, lovely students. You can join this Telegram channel. By that, we have a backup plan there. You can check that. What is the backup plan? Class duration will be maximum of 1 hour only. It may be less than 1 hour. It may be between, say 55 minutes to 1 hour. Okay. So let's get started without wasting time. So first question is, the major product of the following reaction is. Let me know the answer in the chats. Everyone, write down the answer in the chats. This is the question. Question is this. This on treatment with PBr3 first. Let me know the answer in the chats. What will be the answer of this question? Come on. What will be the answer of this question? Come on. So, first of all, we know this is alcohol and PBr3. It will replace this OH by R. So it will result in the formation of this one. First of all, it will result in the formation of this. That means this OH will be replaced by Br. After that, we will be having alcoholic potassium hydroxide. Whenever CX bond is there, alcoholic potassium hydroxide is there, just you have to do E2 reaction. What does that mean? That means remove halogen from alpha position and hydrogen from beta position. But we will remove hydrogen from this beta so that the double bond formed over here is in conjugation with this double bond O. So this will be the major product. So major product of this reaction will be simply this one. This will be the major product. This will be the major product. Let me check how many among you have already given me the answer. Yes, exactly. It's B. It's not A. It's not A because it's not only this on treatment with PBr3. After that it's what we call KOH. That means first OH will be replaced by Br. Then it is E2 reaction. Exactly. After that, second question is on your screen right now. Tell me what will be the answer of this question. Tell me what will be the answer of this question. Come on, quick. Here, some extra information is there. Question says the product P gives positive steric ammonium nitrate test. Steric ammonium nitrate test. Let me tell you, my dear lovely students, steric ammonium nitrate test, in short form you can say CAN test, CAN, CAN test is used to identify OH groups, whether alcohol, whether phenol. It's used to identify OH groups. Okay, now question says the product P gives positive steric ammonium nitrate test. This is because of the presence of which of these OH groups? You have to tell me which of these OH groups, because of which of these OH groups. Have a look. This compound on treatment with chromic anhydride, you know chromic anhydride means CrO3. It's an oxidizing agent. It can oxidize primary alcohol, secondary alcohol, as well as phenolic OH, but it cannot oxidize what we call tertiary alcohol. That means this OH group will remain as such. That means it is the OH which is having number 2. This is because of this presence of this. I mean to say it is due to presence of OH, but which OH? It is this OH that we have, I mean say steric ammonium nitrate test is positive over here. I hope this point is clear. I'm really very sorry because I have a sore throat today, but I hope this point is clear to each and everyone. Let me know in the chats, is this point clear to each and everyone? Quick, let me know in the chats, is this point clear to each and everyone? It's not D, it's not D, it's not 2 and 4. It's not 2 and 4 because chromic anhydride can oxidize phenol as well. That means here this OH will not be present, this OH will not be present, this OH will not be present because they are oxidized. They are oxidized beta. But this OH will be there. When this OH, I mean say tertiary alcohol OH is there, that clearly indicates that positive steric ammonium nitrate test is because of this OH which is having number 2. That means 2 only. Okay. Now, after this, we will be having another question. Question says, in the following reaction sequence or sequence of reactions, the compound D is. Question says like this. You are having CH3CH2OH. Then this on treatment with P plus I2. We know it will replace this OH by iodine. It will replace this OH by iodine. That means first of all, we will get this one. After that, this is A. This A on treatment with magnesium in presence of ether. You know, whenever there is CX bond and magnesium comes in between C and I mean say X bond. That clearly indicates this is what we call the product which we obtain in this reaction. That means this is B and this B is Grignard's reagent known as ethyl magnesium iodide. And we know in case of Grignard's reagent this is negative part and this is positive part. Now have a look. This B on treatment with formaldehyde. That means here, this nucleophile, this will act as a nucleophile. It will attack this electron deficient site and this bond will be broken. That means it becomes CH3, CH2, CH2 and O minus. So it will become CH3, CH2. Now this CH2 has formed bond with this C which is having already 2 hydrogens. So it is CH2. Then this O becomes O minus. To this minus, this MgI will be attracted. So it will result in the formation of this. This is C. This C upon treatment with water, that means hydrolysis, will simply form CH3, CH2, CH2 and OH. This is known as propan 1-ol or this is known as N-propyl alcohol. So it is simply N-propyl alcohol which is the right answer. I hope this point is also clear to each and every one. Now, is this clear? Is this clear? It's not A, it's not A. It is option number D. Option number D. Okay. After this, dear students, have a look. Question says, among the following compounds, which can be dehydrated easily? Have a look. These are alcohols. These are alcohols. First of all, tell me, is this clear to you? Yes, this is clear to me. That means this is clear to you as well. Now, these are alcohols. Remember, dehydration of alcohol. Rate of dehydration of alcohol. Listen carefully. Rate of dehydration of any alcohol. Rate of dehydration of any alcohol is directly proportional to stability of carbocation formed from that alcohol in RDS, in rate determining step. My dear lovely students, have a look. So here, rate depends on stability of carbocation. Now look towards this one. This is primary alcohol. This is secondary alcohol. This is tertiary alcohol. This is primary alcohol. Upon, say cleavage of COH bond, that means when this OH is what we call lost in the form of OH2 positive, because dehydration of alcohol takes place in acidic medium, OH becomes OH2 positive, that will be lost. Here, it will result in the formation of a primary carbocation. This will form secondary carbocation. This will form primary carbocation. This forms tertiary carbocation. And we know tertiary carbocation here among these is more stable as compared to these primary and secondary. I hope this point is clear. That's why as it forms more stable carbocation, hence it will undergo dehydration of alcohol. This alcohol will undergo dehydration very, very fast. After that, there is another question. The major product of the following reaction is, question is there, you have to tell me the major product. Question is like this. You have to tell me the major product, dear students. It is like this. First of all, it's treated with a base K2CO3, potassium carbonate base. That base will abstract this H. That means it will first result in the formation of this one. Have a look. Why this hydrogen? Why not this hydrogen? This is phenolic, this is alcoholic. Phenolic hydrogen is more acidic, so it will abstract phenolic hydrogen. Now, after that, this on treatment with methyl iodide, only one equivalent. So, it will be a normal SN2 reaction. This O having a negative charge, that means a phenoxide ion will act as a nucleophile and it will result in the formation of this product. OCH3, then this CH2, OH, it will remain as such. That clearly indicates it is this one. That clearly indicates it is option number 1. After this, the major product obtained on interaction of phenol. Have a look. It is this one, phenol. With sodium hydroxide, it is this one. We know this is acid, this is base. So normal acid-base reaction takes place and we will get sodium salt of phenol like this. Sodium phenoxide is obtained. Now, this sodium phenoxide and carbon dioxide, then this is treated with, carbon dioxide. We know it results in the formation of this one. This is sodium salt of what we call carboxylic acid. If this is further acidified, then we will get salicylic acid, and this reaction is known as, we will get at that time salicylic acid, orthohydroxy benzoic acid. So salicylic acid is obtained. And this whole reaction is known as what we call Kolbe-Schmidt reaction, or you can say Kolbe's reaction. So this is Kolbe-Schmidt reaction. Now the question says, the major product obtained on interaction of phenol with sodium hydroxide and then carbon dioxide, it results in the formation of major product is salicylic acid, which is option number C. After this beta, we have another question. Phenol, when it first reacts with, sulfuric acid. First it reacts with sulfuric acid. And then with concentrated nitric acid. That means if we take 2 moles of sulfuric acid, we know it results in the formation of phenol 2,4-disulfonic acid. It is written there in your NCERT textbook. It's written. Reaction is not given, but it is written there. So it results in the formation of this. After that, when it is treated with concentrated nitric acid, Here, what will happen? We will get picric acid. We will get picric acid. We will get 2,4,6 trinitrophenol. We will get 2,4,6 trinitrophenol, commonly known as picric acid. That means we will get 2,4,6 trinitrophenol. It is this option. That means picric acid. Very, very simple questions. After this, question is in front of you. First of all, have a look. Is this question visible to each and everyone? Is this slide visible to each and everyone? Let me know in the chats. Yes, this is visible. This is visible. So question is like this. Question is like this, dear students. Question is like this. You are having a ring like this. Then it is like this. CH2, CH2 and then OH. And here it is OH, dear students. After that, question says, if it is treated with, have a look. If it is treated with what we call CrO3, first CrO3. First it is treated with CrO3. Then anything formed over here is treated with SOCl2. SOCl2 and then heat. Have a look, dear students. First of all, we know CrO3 is what we call an oxidizing agent. Now, CrO3 can oxidize phenol, it can oxidize alcohol as well. But the question over here is that if it is, I mean to say, listen carefully, if it is anhydrous one, it will oxidize this. But if it is, say for example, Jones reagent, then it can oxidize this as well. Suppose this is anhydrous, it will oxidize this. This is primary alcohol and it will oxidize this primary alcohol to aldehyde. That means we will get like this. This OH remains as such, then it is CH2, then another CH2, so this is CH2, then this CH2OH will be changed to CHO. I hope this point is clear. First of all, is this CrO3? Is this CrO3? It's actually not visible here as well. That is why. Let me know in the chats. Please, quick. I'm not able to basically make out what is this. Is this CrO3? It's not basically visible over here. Just a moment, my dear lovely students. I will simply do one thing. It is CrO3. Yes, it is CrO3. Yes, it is CrO3. Exactly. It is CrO3. Now, let me take this as hydrated one. So it is CrO3 then dear students, just a moment. Then it will form this alcohol to carboxylic acid, because CrO3, when it is hydrated, it is a strong oxidizing agent. It will convert this alcohol to carboxylic acid. So it is CH2, then COH. CH2, then COOH. Now, dear students, this is treated with SOCl2. This OH will be replaced by, simply replaced by, it is CH2, C, double bond O, then it is Cl. It is replaced by this one. Now, after that, heating is there. That means it will basically do one thing. It will attack this one and Cl will be lost. When Cl will be lost, it is 1, 2, 3, 4, 5 and 6 membered ring which is formed over here. It's a 6-membered ring which is formed over here. So 1, 2, 3. 1, 2, 3. Yes. So 1, 2, 3. 1, 2, 3. So this CH2OH is converted to COH. Then it becomes this one. So have a look. It can be a 6-membered ring or a 5-membered ring. Or let me change this resonating structure in this one. Can we change this like this? Can we change resonating structure like this, dear students? It is double bond over here, double bond over here, double bond over here, because you can use any resonating structure, dear students. Now, let me show you another resonating structure. Please listen it carefully, because this is very, very, very important reaction. Now, have a look. Let me show you once again this one. Let me show you once again this one. So when it is treated with SOCl2, what will happen? It will replace this OH by Cl. So we will get like this. We will get like this. It will be double bond O and then it is Cl, and here it is OH. Now this will attack on this, Cl will be lost. That means it will result in the formation of 1, 2, 3, 4 and 5 membered ring. So there will be a phenol will be there. After that, on this point, it will be a 5 membered ring. On this point, it will be a 5 membered ring. Say for example, this is 1, this is 1, this one is having double bond O as well. This is having double bond O. This is 1, this is 2, this is 3, this is 4, this is, I mean to say 5. Now listen, when 5 forms bond with, I mean to say 1, at that time it's having basically positive charge over here. Have a look. It's actually having positive charge at this position, at 4 position. At 4 position, and there is hydrogen at this position. Finally, because of heating, what will happen? This hydrogen will be lost and aromatization will take place. So it will result in the formation of this product once again. It is phenol, and at this position there is 5 membered ring. There is 5 membered ring, and there is a double bond over here. So 5 membered ring and a double bond over here. So which option is this? It's not clear. Now have a look. Which option is this? So it will be 1, 2, 3. 1, 2, 3. It will be option number B. It will be option number B. I hope this point is clear. I hope this point is clear. Let me know in the chats, is this point clear? Is this reaction clear? This is not visible to me either, but here I mean say, saw the option very well. Now, tell me the beta. Tell me everyone, is this point clear to each and everyone? Is this point clear to each and everyone? Come on, lovely students. Okay, everyone, it's clear. After this, there is the electrophile involved in the reaction. Very, very simple reaction. Phenol and then chloroform. Reaction is this: phenol, chloroform, NaOH, followed by acidification, resulting in the formation of orthohydroxy benzaldehyde, a very well-known reaction known as salicylaldehyde. What is this? This is salicylaldehyde. Now tell me, dear students, tell me, which type of reaction is this? A very well-known reaction known as Riemann-Simon reaction. Riemann-Simon reaction. This is a very, very well-known reaction. Now tell me, what is the electrophile of this reaction? What is the electrophile of this reaction? You know, dichlorocarbene is the electrophile of this reaction. So dichlorocarbene is option number B. Option number B. After this, dear students, among the following, the one that gives positive iodoform test. Listen carefully. Positive iodoform test is shown by which compound? Positive iodoform test is shown by. If we talk about alcohols, then alcohols must contain this group. Alcohols must contain this group. If we talk about aldehydes and ketones, then dear students, aldehydes and ketones must contain this group. Now, have a look towards options. All are alcohols. That means that alcohol which is having this group can show positive iodoform test. Have a look. What is this? OH attached to carbon is known as alpha carbon. That means alpha carbon to which OH is attached, that carbon should contain at least 1 hydrogen and 1 CH3. Have a look. OH is attached to this carbon. It should contain at least 1 H. 1 H is there. But it should be attached to CH3. But it is not attached to CH3. It's attached to CH2 as well as CH2. That means here it should be attached to CH3. So this will not give iodoform test. OH is attached to carbon. That carbon should contain at least 1 H. 1 H is there, but this should contain at least 1 CH3. That means that is not present, so it will not also give iodoform test. What about this one? OH is attached to carbon to which it contains at least one hydrogen, but same carbon should contain CH3, so there is no CH3, so this will not show iodoform test. What about this? OH is attached to a carbon to which there is one hydrogen as well as one CH3, because what is this? It is this structure. Its structure is like this. Its structure is like this. So have a look. Carbon to which OH is attached must contain one hydrogen and one CH3. So this group is present here. Here. So we can simply say that iodoform test will be given by, say this one. That means this alcohol will show positive iodoform test. After that, there is assertion reason question. Assertion is synthesis of ethyl phenyl ether. That means this one. This is ethyl phenyl ether. Have a look. This is ethyl phenyl ether. Can be achieved by Williamson synthesis. Yes, have a look how. If we treat alkoxide, say this ethoxide with, have a look, with this one. This is one possibility. Now the question is that possible or not? I will tell you that. Second thing is that it should be like this. Second thing is that it can be formed like this. Now the question is, among these, this is not possible, this is possible. Why? Because when this attacks this, X will leave, then it will be formed. But this is haloarene. Haloarenes do not show what we call nucleophilic substitution reactions normally, because their CX bond is very strong due to partial double bond character. But this can be achieved easily. This can be done easily. Now the question is, synthesis of ethyl phenyl ether can be achieved by Williamson synthesis. Yes, but with the help of this one. This phenoxide will attack alkyl halide and we will get what we call ethyl phenyl ether. Now the reason is reaction of bromobenzene. That means it is bromobenzene. Say for example bromobenzene. Reaction of bromobenzene with sodium ethoxide. That means it is sodium ethoxide. Yields ethyl phenyl ether. Answer is no, because bromobenzene will not give, say this nucleophilic substitution reaction, and we know Williamson synthesis is normal nucleophilic substitution reaction. It is normal SN2 reaction. So can I say assertion is correct but reason is wrong? So assertion is correct but reason is wrong. Reason is not correct. After this, is this slide clear to you? Let me know in the chats quick. Let me know in the chats quick. Is this slide clear to you? Be with me, because this is a very short session. Be with me. This is very short session. But with the help of these questions, I believe that your preparation for NEET, which is going on 20th, 21st of this June, your preparation will be, obviously, this will boost up your preparation level. So, now have a look. Is this clear? Yes, this is clear on the mobile, but it is not that clear on this. Let me write down reaction first. It is CH3COOH. That means it is carboxylic acid on treatment with SOCl2. This is thionyl chloride. It gives A. This is question. Then this A on treatment with benzene. This on treatment with benzene. I hope so. This on treatment with benzene in presence of AlCl3 most probably. In presence of AlCl3, yes. In presence of AlCl3. Gives B. This on treatment with KCN and results in the formation of C. Now we have to tell what is the product C. We have to tell what is C. Now have a look. Have a look, dear students. Whenever carboxylic acid, OH is there, SOCl2 is there. So let me erase this A. We will simply replace OH by Cl. That means this is Ra. This is A. Simply this is A. Now this on treatment with benzene in presence of AlCl3. This is Friedel-Crafts acylation reaction known as Friedel-Crafts acetylation reaction. So this is acetylation. In benzene, there will be simply COCH3 group which will be introduced. Why? Because AlCl3 will, remove this Cl from CH3COCl, and then it will result in the formation of this carbocation. This carbocation, this acts as an electrophile. It will attack benzene and we will get acetophenone first. I hope this point is clear. Now this is Rb. Now beta, when this acetophenone is treated with, say KCN, it's basically HCN. let me write down over here. It should be HCN. Let me write down HCN in presence of base. Base will abstract. This OH minus will abstract H positive. So this base will generate Cn minus as a nucleophile. So Cn minus will attack this carbon. Cl minus will attack this carbon. Have a look. It will attack this carbon. Say for example, Cn will attack this carbon and O becomes O minus. And here it becomes CH3. But when O becomes O negative, then it will abstract hydrogen from water, because when OH minus abstracts H positive, it becomes water, and that H positive will be abstracted by this one. So in nutshell, we will get cyanohydrin. We will get cyanohydrin. That means reaction of aldehyde or ketone with HCN gives us cyanohydrin. Simple trick is like this. This is positive part, this is negative part, this is positive part, this is negative part. Give negative part to positive part and positive part to negative part. You will get cyanohydrin. You will get cyanohydrin. Now, which option is this one? Which option is this one that we will get cyanohydrin? Is there any option in which this benzylic carbon is attached to CH3, Cn and OH? CH3, Cn and OH. It is this one. It's option number C. Exactly. It is option number C, exactly. Now, next question is major product. Major product B in the following reaction is, you have to tell me the major product. Have a look. Reaction is like this: CH3, CH2, CH, CH3, this is CH2, this is O, this is CH2, CH3. Whenever you are having aliphatic ether, and that too, it is unsymmetrical aliphatic ether on treatment with HI and heat, what will happen? Have a look. If ether is such that there is no group which is alkyl, which is tertiary alkyl, neither from this side nor from this side, at that time we will simply do what we call SN2 reaction. We will break oxygen bond with that alkyl which is smaller one. That means this one, we will give H to this and I to this. I hope this point is clear. So we will get CH3, CH2, CH, CH3, CH2, OH. This will be the alcohol. Another part will be alkyl iodide. But it says that it gives alcohol, that is A. So this is A, this is alcohol. This alcohol on treatment with H2SO4. This alcohol on treatment with H2SO4 means this will get protonated. It will become OH2. When it becomes OH2, it will simply lost. OH2 will be lost in the form of water. So it will be like this. This is CH2, then it will become OH2 with a positive charge. This OH2 will be lost in the form of water, and we will get a carbocation over here. We will get a carbocation over here, dear students. Now, what will happen? This carbocation undergoes 1,2 hydride shift. That means this hydride will be transferred to this position, and it will result in the formation of a more stable carbocation like this. It will result in the formation of a more stable carbocation like this. That means this hydrogen has been changed from this position to this position. Now finally, when we heat it, H positive will be lost. Now H positive will be lost either from this position or from this position. That means from the position which are adjacent to the carbocation. But dear students, this position is having 2 hydrogen, this position is having 3 hydrogen. We know this is having more number of hydrogen. If we remove hydrogen from this and form a double bond here, it will result in the formation of Hoffman product. And if we remove hydrogen from this and form a double bond over here, it will result in the formation of Sadze product. And we know Sadze product here is the major product. That is why major product of this reaction is like this. This is the major product. That means there should be a carbon-carbon double bond. To one carbon-carbon double bond, there should be 2 methyl groups, and to other, there should be hydrogen and CH3. That means it is this one. That means it is this one. After this, there is another question. The major product of the following reaction is, first of all, let me know in the chats, is this, say slide visible to each and every one? Yes, this is visible. Yes, this is visible. That's great. Now have a look. Have a look. Have a look. Here it is. Substrate is like this. This on treatment with HI. What will happen first? What will happen first? Have a look. First, this bond will be broken. This bond will be broken. Give H to this and I to say I to this. That means this becomes CH3I. This becomes CH3I and this becomes alcoholic part. Similarly, break this bond, this give hydrogen to this and I to this. That means this will become phenolic part. Now, I mean to say, first it will result in the formation of a structure like this. First, it will result in the formation of a structure like this. This is OH and this is phenolic part. So, but my dear lovely students, if HI is taken in excess, then what will happen? What will happen? Then break this bond, give H to this and I to this. So, it will result in the formation of this product. But let me tell you, if HI is taken in excess, phenol remains as it is, because this bond is difficult to break. We cannot break this bond because of partial double bond character. This bond is strong. That's why phenol remains as such, but alcohol is changed to alkyl iodide if it is treated with HI. So this is the major product of this reaction if HI is taken in excess. Now tell me which one is the correct option over here. It is option D. It's option D. I hope this point is clear. I hope, dear students, this point is clear to each and every one. Is this point clear? Excess isn't mentioned exactly. Excess isn't mentioned, beta. But according to whenever this reaction is given, you have to check that which type of product can be, formed. It can be formed, it can also be formed. That means it can be formed, it can also be formed. But as it is not mentioned whether it is excess or not, at that time, if both products are given, give preference to, HX in excess. Because whenever HI is there, it can convert easily this alcohol to alkyl iodide. So you have to give preference to HI if it is, having both options, when it is having option like this as well as this. If both options are given, that means if this is given, this is given, means if the product formed after when HI is treated in excess, if that product is given, and if HI is not, treated in excess, that product is given. If both are given, then give preference to HX or HI, which is treated in excess. That product will be formed more, major product. Next, consider the given reaction and the product is. Which type of reaction is this one? This is very, very simple reaction. Have a look. Which type of reaction is this one? You should know which type of reaction is this. Have a look, dear students. Which type of reaction is this? This is aldehyde. This is aldehyde CH3CHO and this one is ketone. Have a look. This is aldehyde. This is aldehyde. This is ketone. This ketone is having alpha hydrogen. This is also having alpha hydrogen. So two different carbonyl compounds on treatment with NaOH but without heat. That means it is aldol reaction. Now the question is, sir, this is aldol reaction. Now the question is, should we remove hydrogen from this position or this position? Remember always, remove hydrogen always from that alpha carbon. That means from that carbonyl compound which is having less reactivity towards nucleophilic addition reaction. And we know aldehydes are more reactive towards nucleophilic addition reaction as compared to ketone, which clearly indicates ketone is less reactive towards nucleophilic addition reaction. That means, dear students, you have to remove hydrogen. You have to remove one hydrogen from this alpha position. So what will we do? Aldol reaction. For aldol reaction, there is a trick, and trick is like this. This carbon is negatively charged and this hydrogen is positively charged. Another. We know we have to, attack from, when we remove hydrogen, it forms a carbanion. We have to attack carbanion from, this will act as a nucleophile and this will act as an electrophile. So what will happen? Have a look. This is positive part, this is negative part. So in presence of NaOH, what will be the product? Product will be like this. Double bond O remains as such. This becomes carbon negative, will form bond with this. That means it will form bond with this. This is already having H. This is already having CH3. Yes or no? It's having double bond. Double bond gets converted to single bond and this H positive goes to this. So this is beta, this is ketone, this is alpha, this is beta. Beta hydroxyketone is known as ketol. So first of all, ketol is formed. This is known as aldol reaction. After that, it is treated with I2NaOH. And after that, When it is treated with I2NaOH, that means this is iodoform reaction. And you know, this alcohol, CH3CHOH, shows iodoform test. So what will happen? Just break this bond, convert this CH3 to CHI3, and convert this. Remember, convert this CHOH bond to CONA. That means it will result in the formation of this. It will result in the formation of this one. It's already having one H, it is CH2H. So let me write down CH2 like this. Convert CHOH into CONA, H is also there. That means it becomes C double bond ONA. So 1, 2, here more bonds are present. So it is CH, it is CH, this is beta carbon. So convert this into C double bond ONA. This double bond is there, this methyl and methyl is there, plus CHI3 is there. And this will precipitate in the form of yellow precipitate will be obtained. Now, this upon treatment with acid is there, HCl is there. So it becomes COOH. That means this is 5-membered ring, double bond O is there. It's a methyl group, then C double bond O, and then OH will be finally this. So which product will be this? It will be option number D. It will be option number D. Is this point clear to each and everyone? Is this reaction clear to each and everyone? Let me know in the chats. Why don't we form alpha beta unsaturated ketone here? Exactly, beta. We will form alpha beta unsaturated ketone only and only if heat is there, or listen carefully, I will tell you a trick. Have a look. This is alpha carbon, this is beta carbon, this is gamma. Remember, whenever you form aldol or ketol, if gamma carbon is having double bond, then you have to form alpha beta unsaturated. Otherwise, you never form alpha beta unsaturated until and unless heat is there. As heat is not there and gamma position is not having any double bond, so form what we call form beta hydroxy aldehyde or beta hydroxy ketone, depending upon whether it is ketone or aldehyde. I hope this point is clear. At the rate of Miru, is this point clear, beta? Okay, understood. Okay, that's great. Now, after this, question is, which one of the following compounds will give orange precipitate when treated with 2,4-dinitrophenyl hydrazine? That means it is 2,4-DNP test. 2,4-DNP test. If you remember, this test is generally shown by aldehydes. It's shown by aldehydes. It's shown by ketones. And formic acid can also show this test. But generally, our NCERT talks about aldehydes and ketones. But formic acid can also show this test. Have a look. First one is ester. So it will not show 2,4-DNP test. Second is also ester. It will not show. Third is ketone. It can show. Fourth is carboxylic acid. It will not show. So it is simply option number C. Very, very simple. After that, question says, it is CH2, double bond CH, single bond CHO. Question says, when it is treated with NaBH4, what will happen? It will reduce this CHO, so it will result in the formation of CH2OH. That means it forms an alcohol. This alcohol on treatment with SOCl2, what will happen? Replace OH by Cl, so we will get CH2 double bond CH, single bond CH2, single bond Cl. Now this is Ra. This on treatment with benzene. In presence of AlCl3 anhydrous. What will happen? AlCl3 will remove this Cl and there will be a positive charge. That means there will be formation of a positive charge like this. So this is the electrophile of the reaction. This electrophile goes to benzene ring. That means we will simply get, this one. We will get this one. It is CH2, single bond CH, double bond CH2. So this is RB. After that, it is treated with DBr. That means this is normal electrophilic addition reaction taking place by a formation of carbocation. It will attack this D. Br will be lost. Br will be lost in the form of Br minus. So what will be the product? Product formation will be like this. CH2, single bond CH, single bond CH2D. Positive charge will be present over here. After that, 1,2 hydride shift will take place. Why 1,2 hydride shift takes place? So that carbocation becomes more stable because of resonance of the ring. Because of resonance of the ring. I hope this point is clear. Finally, Br minus will attack and we will get a product like this. CH, here it will be Br, then it is CH2, then it is CH2, then it is, I mean to say, D. So it is CHBr, CHBr, CH2, CH2 and D. That means it's option number C. It's option number C. I hope this point is clear. This reaction is clear to each and every one. After that, very simple reaction. Very simple reaction. Have a look. We have cyanide. Cyanide upon hydrolysis, we know, converts CN to COH. I mean, say, hydrolysis of cyanide results in the formation of carboxylic acid. Now, this on treatment with SOCl2, what will happen? Replace OH by Cl, so we will get CH3, CH2, C double bond OCl. Then, this is treated with hydrogen and then palladium, barium sulfate. Which type of reaction is this? This is Rosenmund reduction. Convert, I mean, say, replace this Cl by H, so we will get an aldehyde, CH3, CH2, CHO. We will get an aldehyde like this, CH3, CH2, CHO. That means it's option number D. After this, question says, when sodium phenoxide is treated with carbon dioxide, it results in the formation of something which on acidification, which on treatment with acetic anhydride gives what we call C. Which among the following is C? Very simple reaction. We know, dear students, whenever you are having sodium phenoxide and if it is treated with carbon dioxide followed by acidification, always this reaction is known as Kolbe-Schmidt reaction, and we will get simply a product like this. It is OH, then it is COOH. We will get salicylic acid over here. This salicylic acid on treatment with acetic anhydride, CH3CO, O, C double bond O and CH3. What will happen over here? This H will be replaced by acetyl group. That means acetylation reaction takes place and we will get a structure like this. It will be O and instead of H, it will become COCH3. So it is acetyl salicylic acid which is obtained. And acetyl salicylic acid is also known as acetoxybenzoic acid or 2-acetoxybenzoic acid, also known as aspirin. I hope you know this, and the product is OCOCH3, and to that ortho position COOH should be there. That means OCOCH3 and COOH. That means this is the product. This is known as aspirin. After this, very simple reaction, another one. It is CH3 C double bond OOH. I mean, say, carboxylic acid. This on treatment with lithium aluminium hydride. We know what will happen. Give H to this, give H to this, because this is the reducing agent. Break this pi bond, give H to this, give H to this. That means it will result in the formation of CH3, CH2, OH, and this is what we call A. This A on treatment with PCl5, what will happen? This replace OH by Cl, so we will get CH3, CH2, Cl. So this is, dear students, B. This on treatment with beta, alcoholic potassium hydroxide. Alcoholic potassium hydroxide will act as a strong base and there will be E2 reaction. So this is alpha, this is beta. Remove halogen from alpha, remove hydrogen from beta. That means we will get ethene. We will get ethylene or ethene. This is the product. This is the product. Ethylene is the common name. Ethene is IUPAC name. After this, dear students, this is another reaction. Very simple reaction. Very simple reaction. Now, what is this reaction? And try to remember this. Try to remember this. Whenever you are having aniline, and if it is treated with strong oxidizing agent, say for example Cr2O7 in acidic medium, remember beta, it like that of phenol, product will be same as that of phenol. That means it will result in the formation of benzoquinone or parabenzoquinone. Remember this. So oxidation of aniline by using strong oxidizing agents like acidified potassium dichromate results in the formation of what we call benzoquinone. After that, dear students, question here is very simple question. Aniline is given. Aniline is there. Aniline on treatment with, it is CH3, C double bond O, and then it is O, then C double bond O, then CH3. That means it is simple acetylation reaction. What will happen now? This hydrogen of aniline will be replaced by acetyl group. Hydrogen will be replaced by acetyl group. It is like this. So this will be the product. This is A. Now this on treatment with bromine in presence of CH3COH, what will happen now? Bromination will take place now at ortho as well as para position. But when bromination takes place at ortho, because of repulsion, that will be minor. That means major product will be like this. Major product will be like this. Bromine will go to para position. This will be the major product. So this is what we call RB. This is what we call RB. Now you have to check which one is A, which one is B. This is A, NHCOCH3. This is not A. This can be A. This can be A. Only three options are there. So this can be A, this can be A. Now, which one is D? Which one is B? This is not B, this is B. So this is the major product. This is the major product because bromine goes to para position. So this is its option. This is its option. Option D is missing over here, but our question, our answer is, is still over here. Now, I hope this point is clear. First, acetylation and then bromination. Bromination can take place at ortho as well as para, but para will be the major because if bromine goes to ortho, this will be minor because of steric repulsion. I hope this point is clear. After that, primary, secondary and tertiary amines can be separated by using, very, very simple. This can be separated by using Hinz-Burgess reagent. By using, say a test known as Hinz-Burgess test. And during Hinz-Burgess test, we use basically Hinz-Burgess reagent. We use Hinz-Burgess reagent. And what is Hinz-Burgess reagent? What is Hinz-Burgess reagent? Listen carefully. It is this one, benzene sulfonyl chloride. But it is written in your NCERT textbook that this benzene sulfonyl chloride nowadays is replaced by paratoluene sulfonyl chloride. That means you can use, this is Hinz-Burgess, you can use this, you can use this, depending upon the reaction now. Now, it is paratoluene sulfonyl chloride. It is this paratoluene sulfonyl chloride. This will be the simple option. After that, aniline upon nitration gives ortho, meta as well as para. That means it gives para, meta as well as ortho. But we know NH2 group is basically, NH2 group is actually ortho and para directing group. Then how can this meta is formed, and that too 47%? Answer is simple, because in acidic medium it results in the formation of anilinium ion. And we know this anilinium ion is meta directing group. That's why nitro group nitration takes place at meta as well. That means it is formed because of formation of anilinium ion. Very, very simple. After that, carbyl amine test is used to detect presence of primary amino group in an organic compound. Which of the following compounds is formed when each test is, what we call performed with aniline? You know, primary amine, whether it is aliphatic or aromatic, when it is treated with chloroform in presence of alcoholic potassium hydroxide, we know a bad smelling compound, foul smell compound known as isocyanide is obtained, also known as carbylamine, also known as isonitrile. That means it is obtained because of that bad smell. We can simply say our compound is what we call primary amine. So this is basically that bad smell compound known as isocyanide. And from aniline, we will get this one, phenyl isonitrile or phenyl isocyanide. After that, question says, if aniline, sorry, this is not aniline, it is para-aminobenzene sulfonic acid. If you are having para-aminobenzene sulfonic acid, this on treatment with NaNO2 HCl at 273 to 278 Kelvin, what will happen? This is simply diazotization reaction. First of all, NH2 will be converted to N2Cl. That means a diazonium salt will be obtained. It will result in the formation of this one. Now, after that, this on treatment, this diazonium salt on treatment with, this on treatment with N-dimethyl aniline. This is simply coupling reaction. This is simply coupling reaction to this. This is electrophilic substitution reaction. This will donate electron. It will increase electron density at ortho and para. But this will prefer to go to para so that there will be less repulsion and major product will be at para. That means product will be like this, beta. Product will be like this. is N-dimethyl aniline, and to this para position, to its para position, it's this diazonium ion which will be attached, and we know here it is also SO3H group. SO3H is also attached to this. That means our option will be, this is simply coupling of N-dimethyl aniline taking place at para position. So it is this one. It is this one. It is this one. And this reaction takes place in generally acidic medium. This coupling of aniline takes place in acidic medium. I hope this point is clear. I hope this point is clear. My dear lovely students, is this point clear? Quick. Because we are having few more questions. Tell me quickly. Is this point clear? Okay. After this, dear students, question says nitrobenzene, C6H5NO2 means nitrobenzene. Nitrobenzene on treatment with SnHCl. What will happen? It will simply reduce this NO2 to NH2. That means we will get aniline. We will get aniline. So this is A. This aniline on treatment with C6H5NH2, C6H5NH2, C6H5N, sorry, not NH2, N2Cl. That means benzene diazonium chloride in acidic medium. Once again, a coupling reaction, and coupling takes place at its para position. So it will be like this NH2, and to this NH2, coupling will take place at this position like this. So we will get a product. We will get a product. This product is known as para-amino azobenzene. Para-amino azobenzene is option number 1. Para-amino azobenzene is option number 1. After this, which of the following reactions will not give para-amino-benzene? Now have a look. This is nitrobenzene. Nitrobenzene on treatment with SnHCl first results in the formation of aniline. Aniline on treatment with HNO2 gives diazonium salt. Diazonium salt on treatment with aniline gives para-amino-benzene like this. Gives para-amino-benzene like this. Azobenzene like this. Para-amino-azobenzene will be formed over here. Now, NO2 cannot be reduced by NH2, so it will not form. This NH2 on treatment with HNO2 will form diazonium salt. Diazonium salt on treatment with aniline, it can, also form. So the question is, which of the following reactions will not give amino-azobenzene? It is only option B. Only B. Only B, because this can form, this can form. Only B is the right answer. Only B is the right answer. After this, very, very simple reaction. Have a look. Very, very simple reaction. Have a look. Reaction says it is like this. Now, this on treatment with NaNO2. This on treatment with NaNO2HCl. That means diazotization once again. 273 to 278 Kelvin. What will happen? Diazotization. Convert this NH2 into N2. Convert this into N2Cl. Have a look. This will be para. This will be bromine, sorry. So this is X. This on treatment with Cu2Br2. Which type of reaction is this? When diazonium salt is treated with cuprous halide, this is Sandmeyer reaction. Now this N2 will be replaced by bromine. N2 will be replaced by bromine, dear students. So it will be this one. Now this on treatment with HNO3, H2SO4, that means nitration. Nitration will take place at ortho as well as para position with respect to bromine, with respect to anyone. Say for example, with respect to this ortho or this ortho will get nitro, but they will be obviously this nitro. If nitro goes to this position, there will be more repulsion. So nitro will prefer to go to this ortho position or to this, para position with respect to this. So have a look. So product can be simply, major product can be with respect to this bromine, NO2 will go to para position, or with respect to this bromine, NO2 will go to this position. That means only one NO2 will be added, either para with respect to this bromine or para with respect to this bromine. Now have a look. One NO2 should be present. This will not be the product. This can be the product, but this is not para with respect to any one of these, bromines. Now, this NO2 is para with respect to this. That means this can be the product. This NO2 is in between this. This can never be the product because there will be steric repulsion. So the major product of this reaction is this one. After this, very good question. Now have a look. NO2 has to be changed to this one. What will we do? We will simply react. Now have a look. If we treat NO2 with bromine, what will be the product? What will be the product? If we treat NO2 with bromine in presence of Fe, it will result in the formation of FeBr3 positive. Bromine and FeBr3 positive results in the formation of Br positive, and Br positive will go to meta position with respect to NO2 because this NO2 is meta directing, so it will result in the formation of this. Now, after this, dear students, if we treat it with SnHCl, NO2 is changed to NH2. NO2 is changed to NH2, so this will be the product. After that, if we treat it with NaNO2, HCl, 273 to 278 Kelvin, I mean say diazotization will take place and it will result in the formation of N2Cl minus and plus. This is having bromine. And finally, if you treat it with CuBr, HBr, this is known as cuprous bromide. That means once again a Sandmeyer reaction. It will replace this N2 by bromine and we will get this one. That means it is simply option number second. Option number second is the correct answer. After this, very simple reaction. Very simple reaction. First reaction is like this. It is benzene and then it is like this. It is like this. It is like this. Have a look. It is simply, it is not like this. It is simply, let me color this. It is AlCl3 over here. AlCl3 over here. Is this clear to you? Is this visible to you? So remember, it is AlCl3. So this is anhydride. Anhydride in presence of AlCl3. What will happen? AlCl3 in presence of anhydride. What will happen? It will attack this one. It will acquire a positive charge and this bond will be broken. That means now positive charge will acquire on this. That means we will get a electrophile like this. Have a look. We will get an electrophile like this. This is having negative. This is having negative charge. Negative charge. This is positive charge. This positive charge goes to this position. It goes to this position. I hope this point is clear to you. When positive charge goes to this and finally this will be lost and OH will be added. That means it finally results in the formation of this. Have a look. It is benzene. To that benzene, C double bond O is there. After that, it is CH2, CH2, COH. Then it is CH2, CH2, and then C double bond O, OH. So it will be like this. First of all, it is benzene, that means phenyl ring. After that, it is CO, then CH2, CH2, COH. That means CO, CH2, CH2, COH. Either this one, CO, CH2, CH2, COH, or this one. That means it is either A or C. But this on treatment with zinc amalgam HCl, that means Clemmensen reduction. Convert this ketone into CH2. This has changed COH as well. No, this is not the answer. COH remain as such, but only C double bond O will be changed. That means this is RB. It will become CH2, 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 and then COOH remain as such. That means it is option number 1. It is option number 1. After this, question says, most suitable reagent for the conversion of primary alcohol to aldehyde, it should be simple, say mild oxidizing agent, and that too among mild oxidizing agents, remember it's Corey's reagent or pyridinium chlorochromate, which is considered as the most common and most suitable reagent for conversion of primary alcohol to aldehyde and secondary alcohol to ketone. After this, question says, you are having an alcohol like this. Question says you are having an alcohol like this when it is treated with H3PO4. That means acidic medium. First, this OH will abstract H from this and it will be lost. Say for example, let me show you the reaction. It will result in the formation of this first. A positive charge. It will be lost in the form of water. And it will result first in the formation of a carbocation like this. Now this hydride shift will take place. That means 1,2 hydride shift will take place so as to form more stable carbocation first. So it will result in the formation of this carbocation. I hope this point is clear to you. But my dear lovely students, as heat is also there, so this hydrogen will be lost and it will result in the formation of this alkene. It will result in the formation of this alkene first. After that, hydroboration oxidation. That means B2H6, it is BH3 or BH3 whole 2. It's one and the same. So this is hydroboration will take place from this and oxidation with this one. Now, whenever you saw this type of reagent, you have to add water across carbon-carbon double bond, but according to anti-Markovnikov's rule. That means negative part of water goes to that carbon-carbon double bond, which is having more hydrogens. That means this will be the product. This will be the product, and this product will be anti-Markovnikov's product of addition of water. That means you have to add water, but according to anti-Markovnikov's rule. According to anti-Markovnikov's rule. So it is this one which is the correct option. After this, the main product of the following reaction is, main product of this reaction, have a look. It is C6H5, that means it is phenyl ring like this. Then it is CH2, then it is CH, then it is OH, then it is CH, then it is CH3, then it is CH3. This on treatment with H positive, what will happen? What will happen? It will simply abstract H positive and it will result in the formation of this CHH. Can I write down this in this fashion? Then it is OHH with a positive charge. Then it is CH3. Then it is CH3. What will happen, dear students? It will lose water molecule. Once water molecule is lost, dear students, what will be the intermediate formation over here? Carbocation will be formed, beta. When carbocation is formed, now it will undergo rearrangement, but we will form, more stable carbocation. That's why I will shift 1,2 hydride shift in such a way so that the carbocation form becomes more stable because of resonance of the ring. So it will result in the formation of CH, then CH3, and then CH3. I hope this point is clear. So this carbocation will be obtained first. After that, because of heat, it will lose water molecule. Sorry, it will lose hydrogen, H positive. It will lose H positive from this position. This is not having H. This position, it will lose H positive. So we will get phenyl, then CH, then double bond CH, and to that double bond, it is CH, CH3, and CH3. That means it's carbon-carbon double bond. On this carbon, it is H and phenyl. On this carbon, it is H and isopropyl. Now, have a look. Phenyl CH, double bond CH and isopropyl. This cannot be the product. Okay, this cannot be the product. CH, double bond CH, and this is what we call isopropyl. This and this, one and the same. One and the same product. So these two are one and the same products. So this is the major product. C6H5. But no, this is cis, this is trans. Remember, trans is more stable. As they are both same, but trans is more stable, hence major product is trans. Because in cis, these groups are, say, closer to each other, there will be repulsion. In trans, they are farther away from each other, there will be less repulsion. So both products can form, but this will form in major quantity. So this is the major product. Trans is always major product when cis and trans both are formed. Now, very simple reaction another. It is alcohol, CH3CH2OH on treatment with phosphorus and iodine. But we have discussed this question most probably. We have discussed this question. It is N-propyl alcohol. We have discussed this question. After this is another question, a very important question and a very good question. Now have a look. Question is like this. Question is like this. Question is like this, and this is a very good question. This is a very good question. One group is cyanide, another is, ketone on treatment with methyl magnesium bromide followed by hydrolysis. Remember. Methyl magnesium bromide means Grignard's reagent. Grignard reagent can attack this. Grignard reagent can attack this. It can attack both when they are 2 moles followed by hydrolysis. Let me write down direct product of this reaction. Remember, dear students, it will convert this into OH and CH3. This CH3 is already there because ketone is converted to tertiary alcohol. Now, it is like this, and it will convert this cyanide to C double bond O and CH3. That means ketone. It's like this. After that, it is treated with H2SO4 and heat. H2SO4 and heat means OH first abstracts proton, becomes OH2 positive. Then it will be lost, carbocation will be formed, and after that carbocation is formed, that because of heat, H positive will be lost. Carbocation will be formed here, hydrogen can be lost from this position or this position. But if I mean say remove hydrogen from this position, double bond will be formed over here. If I remove hydrogen from this, double bond will be formed over here. This double bond and ring, they are in conjugation. That's why major product will be like this. Major product will be like this. OH will be lost in the form of water. Major product will be like this. Major product will be like this. Now tell me which one among these is this product. It is CH3CO. No, these two can never be the product. So either this or this, both can form, but major product will be this. Both can form. Double bond can be formed over here. Double bond can be formed over here. But this double bond is in conjugation. That's why this is the major product. Next reaction is RCN on treatment with diol H, I mean say diisobutyl aluminium hydride, followed by hydrolysis. We know it converts cyanide to aldehyde. So question says, consider the above reaction and identify Y. Y is RY. So what is Y? Y is aldehyde group. So Y is aldehyde group. After that, you have to match the correct match between item 1 and item 2 for the preparation of what? Benzaldehyde. You have to check benzaldehyde. Have a look. Benzene is first one. From benzene to benzaldehyde, how will you convert benzene to benzaldehyde among these? Have a look. We will use this one. We will use COHCl, AlCl3. This is known as Gattermann. This is known as Gattermann's-Koch reaction. This is Gattermann-Koch reaction. I hope this is clear to you. Now, so I can simply say one is R. One is R means either C or D. Now, second is benzonitrile. Benzonitrile is this one. Benzonitrile to benzaldehyde. That means you have to convert cyanide to CHO. Among these, you have to choose. We will use HCl and SnCl2. So HCl, SnCl2. Followed by hydrolysis. This reaction is known as Stephan's reduction. Stephan's reduction. That means, dear students, we will simply use 1R2P. 1R2P. Which option 1R2P? Which option is this? It is C option. Obviously 3 becomes, I mean to say, what we call Q. This is benzoyl chloride. Benzoyl chloride to benzaldehyde. Have a look. Benzoyl chloride is this one. Benzoyl chloride to benzaldehyde. You know this reaction is known as what we call Rosenmund's reduction. This is Rosenmund's reduction. Palladium, barium sulfate and with small amounts of sulfur or quinoline. This is known as Rosenmund's reduction. Rosenmund's reduction. I hope this reaction is clear to you. So it is very simple. 1R, 2P and 3Q. Next question is aldol condensation question. This is aldol condensation question. It's a question which is known as aldol condensation. How? This is aldehyde containing at least 2 alpha hydrogens. First, it on treatment with dilute NaOH without heat gives X. That means that will be a what we call aldol reaction. After that, once aldol reaction product is formed, if it is heated, then Y, it is aldol condensation. Have a look. I will form two. I will interact with these two with similar type of, ketones with 2. Now what will happen now? As both are similar, now you can simply do one thing, remove hydrogen from this and give that hydrogen to this. Then what will be the product? Product will be like this. This will be double bond and then here it will be this C. Have a look. It will be this C which is attached to it, and to this it will be OH. It will be OH like this. So this is alpha, this is beta. So beta hydroxyketone, this is ketol. So this is RX. This upon heating will lose water molecule. We know from alpha remove hydrogen and from beta remove what we call OH group. That means there will be a double bond between these two rings now. So you have to choose which one is X and which one is Y. Which one is X, which one is Y. Have a look. Y is having double bond. Double bond is having this and this. So this can be Y. But after that, you have to choose what is X. What is X? X is C double bond O, then OH. Both options are correct. Both options are no. This is having double bond in ring as well. No. This is having only exocyclic double bond. So it is this one. It is D. It is not B. I hope this point is clear. This is the last question, my dear lovely students, of this session. Now, question says increasing order of the following compound towards HCN. What is HCN addition? This is aldehyde, 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 aldehyde. We know. This is simply nucleophilic addition reaction, and remember nucleophilic addition reaction is what we call rate of nucleophilic addition reaction is increased if electron withdrawing groups are attached, and if electron withdrawing groups are attached, then rate will be increased. If electron donating groups are attached, rate will be less. So what type of group is this? Is this having any effect on CHO? Yes, this is having, but due to minus I. Is this having? Yes, because of minus I as well as minus R. That means it becomes stronger group. Minus electron withdrawing group. It is stronger electron withdrawing group. This is having stronger plus R. That means this is electron donating. This is having minus I group. That means this is having donating. Donating means its rate will be very less. So it will be first. Third one will be first. Third one will be first means either D or C. Third first. After that minus I first. But this is having stronger minus I, this is weaker minus I. That means third, then 1. Third, then 1, then 4, and then afterwards it will be 2. So third, 3, 1, 3, 1, 4, and 2. 3, 1, 4, and 2 means 2 is the compound which shows addition of HCN. That means nucleophilic addition reaction very fast. After that, it is actually 4. After that, it is actually 1. And this is least reactive towards nucleophilic addition reaction or addition of HCN. My dear lovely students, this is all about what we call today's session. I hope everything is clear to you, and thank you. God bless you all. Thank you very much to all of you. And if you liked today's session, then I will be waiting. Once I end this stream, I will be waiting for your reply in comment box. How much you like this session and where from you are watching this session, today's session. So take care. Bye-bye. And God bless you all. We'll meet tomorrow in next session. Till then, take care. Bye-bye and love you all.